You want to use your time as productively as possible. Semantic search reduces the time you need to search for and analyze information. Searches become more flexible and the results more accurate. Semantic search provides an artificial intelligence augmented productivity platform that you can access anywhere and ask anything. When you need support solving a hard problem, this means better time management, increased effectiveness, and improved productivity. Traditionally, any information that may be of help is locked away in an ever-growing avalanche of documents. If you're lucky, these documents are organized in a library, sorted by date and indexed by topic. For a long time, this was the gold standard of managing knowledge. With the World Wide Web, everything changed. Documents were opened up and cross-referenced. They weren't islands anymore, but became part of a hyperlinked global information superhighway. To this day, though, search engines emphasize a small set of popular documents, those that are cross-referenced most often. The information you seek, the valuable knowledge that makes a real difference, remains buried. To overcome issues like information overload and filter bubbles, the next generation of search engines needs an unbiased way to extract meaning and intent from the overall content stored in the information library. The knowledge encoded within the lines of text will be unlocked, and new knowledge can be inferred by reading between those lines. But how can that be done? How can such knowledge become computable? To understand this, let's take a step back and look at the nature of knowledge. Essentially, knowledge is the awareness of validated interconnection of details, which in isolation have less value. Some details and their relationships are well known to us and form the foundation of our experience. These interconnected details are the backbone of everything we learn, invent, and create. Some details are known, but just barely connected to our main body of knowledge, or maybe not even connected at all. Without context, these details are mostly lost. Sometimes, though, these disconnected details may suddenly be activated because they fill in a missing link. That's when inspiration hits. And then there are the things we don't know anything about. These unknown details may contain the link needed to solve a problem. We need an efficient way to learn about these details and how they relate to the things we already know. The details can originate from any accessible information stream. Such a graph of interconnected details is called a knowledge graph, or semantic network. That is the foundation of our semantic search system. Now, if we go back to our web of hyperlinked documents, we need an automated method to extract the semantic network that encodes the knowledge hidden in these documents. Let's look at an example. Within any of these documents, we can identify written text and dive deep into each sentence. For each sentence, we analyze its grammar and identify the concepts that express an idea or assertion, the pieces of detail that will eventually contribute to the semantic network. The identified concepts create triples, or related concepts with a known mode of interaction. The identified triples may be known already, or they may add new relations to the semantic network. The new evidence supporting the identified triple is attached to the semantic network, and over time adds weight to the assertions encoded. This weighted semantic network can be mined for knowledge. Ideas and assertions are validated and prioritized by the amount of supporting evidence attached, not merely by popularity. If we go back to our original information stream, knowledge can be extracted beyond the written text. Some documents may contain images that we can analyze, database references that add context to the identified concepts, or any type of structured data. Specialized data detectors identify details that would otherwise remain hidden. For example, this document contains two-dimensional chemical structure drawings. Using specialized optical structure recognition algorithms, we detect those structures and make them searchable. The detected chemical structures add details to the global semantic network. Semantic search incorporates all this knowledge and makes it accessible in a simple search interface. This sophisticated question-answering system uses artificial intelligence augmented search algorithms that mine the semantic network, allowing it to deal with an ever-increasing amount of data. If you enter a question using natural language, it's analyzed using the same natural language processing algorithms used to extract knowledge from publications. Machine learning algorithms determine the expected type of answer. For example, a person, a time, a location, or an object. Your question is translated into a set of triples containing placeholders representing the answer you seek. Your question is then matched against the global semantic network. The search doesn't just look for direct matches, though. It utilizes complex inference rules and additional machine learning models to give you the answers you seek. Semantic Search, a new search platform that you can access anywhere to get your questions answered faster, to get answers without bias, and find data of interest smarter and more simply than any other system. It can revolutionize how you work with information and accelerate the innovation cycle.